Professor Marc Henry, in the article is Thermodynamics of Life, you write about fossil concepts which are a real problem to make progress in science. You mention several of these fossil concepts and understandings, like having several different energies or the misunderstanding of entropy. And what, in your opinion, needs to be done and what needs to be cleaned up so that science can make progress especially in the understanding of life, biology and medicine?
Yes, the first thing to do is to make a list of what concepts are okay and what concepts should be put in au placard, say in a place where we should never see them again in science. And this list should be very critical because fossil concepts are everywhere in science. And in fact, this is quite logical because science progresses by steps. And of course, when you are interested in a new field of research, at the very beginning, you make errors, wrong way of thinking because it's new. And so you are not the mind sufficiently clear to see where you are going. So you go everywhere and then you get explanations, which are more or less what I call ad hoc explanation. That is to say, it's not very in line with scientific knowledge. And then with time, you have a decantation, wrong ideas disappears, and emerge a knowledge which is in full coherence with all the other knowledge that you have in other branch that have been well investigated for a long time. And here is the trouble. It's not with research, because in research we are out to always work on subjects which have never been investigated before, but it is with teaching. To say, in order to become a researcher, we have to go to school, to university, and teaching is always to textbooks. And here it is in textbooks that we find the fossil concepts. And it will be a little bit hard to say that we must discard most textbooks. If we want that this fossil concept would be no more considered again, we have to put this book in libraries and never open them. Write new books where we have the good ideas which are explained, and students should go to these books, to the new books, not to the old one. And of course, before students, teachers should be aware that there are old books and new books, and usually it's we still need old books, because when you go to old books, you get the very beginning of the field. And so when you go to this book, things are not clear, but if you are clear in your mind, you can make how we call this in English, the
distinction.
The tri.
The distinction, the separation.
Sort.
The sort.
You are able to sort this is okay, I keep. This is not okay, I discard.
Yeah.
And of course, but these books, which were written at a time where the knowledge was not full, this should be a work of specialists, not of teachers. And from this, you can write new books which are more in line with a coherent knowledge. And of course, when you say that, you see the problem. Because the textbooks they are very popular textbooks. And when textbooks are very popular, saying, oh no, you should not read these books, could be a problem. Why they have been so popular? And the idea is that they have been so popular because they oversimplified. But for instance, for entropy, you say entropy measures a disorder. Scientifically speaking, this means nothing. It's a nonsense. But if you want to explain what is entropy to a layman, which is not a scientist, he sees what is disorder. He knows what is disorder because when you are in your house, you want to have order. And when you are moving in the house, disorder appears. But the point that you should be aware is that this disorder appears because you move things. Otherwise, in other words, it's because you have energy that you have disorder, not entropy. And here it is a danger of vulgarization. That is to say, trying to take a concept, scientific, and try to explain this to people who are not scientists. And here there is a danger of oversimplification. And it could be done, of course, for pedagogical purpose, but the danger is that when these errors propagate in time. Because there is a saying, we say that an error, if you repeat it again and again, it becomes truth. This is a problem with the human mind. That is to say, you have a wrong idea, but if it is repeated, finally your brain say, okay, it's good. And this is a real danger for scientists to repeat again and again wrong ideas, fossil concepts, and then after you think that these fossil concepts are the truth. And in fact, they are not, so big problems after when you want to go further. This fossil concept, instead of bringing you new inspiration, they send you back to the past, and they prevent progression of science. So yes, we have to clean all this stuff, and maybe we can go much farther than now from the scientific point of view.
Well, you have studied basically all your scientific career water.
Yeah.
And there's a lot to say about water. We have still this idea, it's just the bonding of hydrogen and oxygen. But it's much more complex than that. And we are made, first of all, of water. We're mainly water. So can you tell us a bit about the importance of water to understand life, health, and disease better?
Well, for me, I have a formation of chemist. So I discovered biology and medicine at a very late time in my career. Before, at the beginning, I was interested in the chemical properties of water and what you can dissolve in water. For instance, we know that there was 92 elements in the periodic table. And one of my subjects, aim of my PhD thesis was to take each element one by one and trying to understand under which form you can find it in water. So I was interested in the interaction between the periodic table and water. And then I discovered that among all the elements of the periodic tables, you have only a small subset of these elements that are used by life. Life does not use the whole periodic table, just a smaller subset. And of course, rise the question, why is this set? Because as soon as you say a subset, there are billion of subsets of 92. And if we look at what is life, we get not a billion of subsets, but one subset, which is very accurate, very clean. And we know that these elements are vital for life, and the other one, we call these poisons. Because life, if evolution has not selected this element, it was probably because it gives rise to disease or to death. For instance, if you take arsenic, you will be in bad shape. Even if at the past time, arsenic was a remedy. But now, no more. Otherwise, you are very ill by it. So you have this idea that finally, what I've done in my thesis was very helpful, because in my thesis I was interested by how the periodic tables behave in water. And now I discovered that in biology we are made mainly of water. So for me the job was made, without knowing that I was in fact already working for biological system, because I have treated biological system without knowing that I was doing that. And of course all the other elements which are not in biology. And now, I have already explained this yesterday. Why water? Because water is the most abundant substance in the universe. So, if you want to have life somewhere in the universe, of course, you will call water, because it will be on a statistical ground, it will be crazy not to use water, because you will use elements that are much less abundant than hydrogen and oxygen. So for me, the reason is pretty clear. We should use water because it is the most abundant. Then I discover another property of water, which is called cohesive energy. That is to say, in chemistry, you have several kinds of bonds. We have what we call covalent bonds. That is to say, two atoms meet, and then they exchange electrons. And when you exchange electrons between two atoms, usually these two atoms, instead of being separated, they become bonded. We call this a molecule. Molecule is a system of atoms which are linked together by chemical bonds. And here we have to go to the numbers, because we want to be clear and scientific. And of course, if you don't give the number, we miss an essential point in science. So I will give you a number, and this number will be not an entropy, because here I am not interested in life, I am interested in how strong is the bond. For instance, I have oxygen, hydrogen, how strong is this bond? And here, a good way of speaking of the strength of a bond is to identify an energy in this bond. And here we have to choose a unit. Unfortunately, we cannot take the international unit of energy, which is the joule, because the joule is a big amount of energy. It's the energy that you get when an apple, which is 100 grams, fall from 10 meters on Earth. So the joule is a unit for macroscopic phenomenon. If we go to atoms and molecules, we have the Avogadro numbers, which is 10 to the power 24. That means that you should divide the joule by 10 to the power 24. And so you get minute amount of energy. But there is a very convenient unit, which is the zeptojoule. Zepto, it means 10 to the power minus 21. And we say zeptojoule. They say we take the joule and we multiply by 10 to the power minus 21. And we get this unit, which is a good unit for chemistry and biology. To say everything in chemistry and biology works around zeptojoule. This is quite different, for instance, what happens in the nucleus of an atom, where here it's not zeptojoule, but it is not zeptojoule, but femtojoule. Is to say 1 million more energy in the nucleus than in the bonds between the atom, which is due to the electron. So we have 1 zeptojoule. And why this unit is convenient? Because now I will say 25 Celsius. What does mean 25 Celsius from a physical point of view? Of course, it is a level on the thermometer, but this is not what I want to... This is obvious. We have discovered that temperature measures the average kinetic energy of a system. You say when you say 25 Celsius, you have a certain amount of average energy. You have molecules we have less energy. You have molecules we are larger energy, but you get an average. And when you say 25 Celsius and you use the Boltzmann constant, which is an entropy, but you multiply by temperature to get an energy, you get 4 zeptojoule. 4. That is to say, as soon as you are here at room temperature, 25 Celsius, nature gives you 4 zeptojoule. For making things. And we immediately see the importance of this number 4 zeptojoule. In the body, it's not 25, it's 37. But this means it is not 4 zeptojoule, but 4.2. We can skip 4. That means that if you have 2 atoms which interact with an energy which is less than 4 zeptojoule, they cannot remain bonded. Because in the average kinetic energy, you have enough energy to break the bond. But if you have now a bond which is larger than 4 zeptojoule, the kinetic energy is not large enough in the air for breaking the bond. And now you will get a structure, not a gas. Maybe a liquid, or if you are with very strong bonds, you will get a solid. So you see the importance of 4 zeptojoule. Of course, if I go to 1000 Celsius, I will get much more energy, and things which are solid at 25 could be fused or vaporized at a higher temperature because I bring energy in the system and I can break stronger bonds. The higher the temperature, the more difficult it is for chemical bond to keep bonded for the atoms. So, okay. So now this is our reference point, and we should put water now, here. And here it becomes a big mystery. The real importance of water for biology is that in water, the bond between hydrogen and oxygen, the covalent bond, which is responsible for the H2O formulation of what we call water, this is, I would say, 1000 zeptojoule. Typically. I will not go into the accurate numbers, just order of magnitude. 1000 zeptojoule. At room temperature, you have 4. So you understand that at 1000 zeptojoule of strength of bonding, water molecules is a very stable molecule. You will not have dissociation between oxygen and hydrogen. You will keep water as H2O. That's the first step. Water is a very stable molecule. But this is not the only one. We have methane, we have carbon dioxide, we have carbon monoxide, we have diamond. There are plenty of substances that are strong covalent bonds. The next step is to say, okay, now we have molecules. How do molecules interact each other? And here comes a big mystery with water. Because we can compute this with quantum physics, how two molecules interact in terms of energy. And when we see, we have a rule, in fact. This is called what we call van der Waals bonding. Van der Waals bonding is a very common thing. It is the sticking of matter. I think that you have all in mind that there are substances which are sticky. Say they stick together, and you have other substances that are not sticky. And the idea is that all the substances that are sticky have a huge molecular weight. They are polymers. As soon as you have polymers, you get sticky things. If you are not polymers, but small molecules, it's not sticky. And we can make this more precise. This bonding is proportional to the number of electrons. And this is why polymers are always sticking, because a polymer, it's a huge number of atoms. So, a huge number of electrons. And the more electrons you have, the more sticky you are. The less electron you are, the less sticky you are. And we can take, for instance, methane, which is a combination of carbon and 4 hydrogen. If you compute the number of electrons, it's 6 for carbon plus 4, because you have 4 hydrogen, each hydrogen has 1 electron, so 6 plus 4 equals 10 electrons. This is a very small amount. So methane is not sticky. When you take 2 molecules of methane, they will not be sticked. They will have a sticking, but it will be much less than 4 zeptojoule. And so, at room temperature, methane is a gas. But now you take water, H2O. It's oxygen, 8 electrons, and 2 hydrogen, 1 electron for each. 8 plus 2 equals 10. The same than methane. But water is liquid, not a gas. Water, if you take from what we know from the behavior of electrons, should be a gas. It is not. Why? This is a big mystery. Why water is sticky? It has a so small molecular weight that it should not be sticky. It should be a gas. But experiments show that it is a liquid. And it is worse than that. That if you go below 0 Celsius, it is not only, it doesn't remain a liquid, it becomes a solid, which is called ice, at 0 Celsius. That means that we can make ice with methane, but it is at a temperature which is not 0 Celsius. It's minus 250 Celsius to get the methane as a solid. So this is a mystery. Water is very sticky. And of course I say sticky, but because I don't want to be too much technical, the good word, the accurate word is cohesive. Water is a cohesive substance. That is to say, when 2 molecules of water meet, they stick together and you have a cohesion. And this is why water is liquid at room temperature and not a gas. And now I will give you the order of magnitudes of this ticking. It's 20 zeptojoule. 20. Not 1,000 like hydrogen and oxygen, but 20. 20 is 5 times 4. That is to say that this ticking is quite strong. Because at room temperature, you have only 4 zeptojoule. Here you have 20. That means that, of course, this is why water is liquid or solid, because you have this bonding, and chemists have a name for this bonding, it's called hydrogen bonding. They say that the hydrogen has a small deficit of positive charge, and oxygen has a small negative charge, and this attract according to Coulomb's law, giving rise to hydrogen bonding. On the paper, it's very nice explanation, but it's completely wrong. Because when you go to the number, you don't get 20. You get at least 4 or 5. You miss most of the energy is not in the electrostatic bonding. And here is the first point, which was the beginning, in fact, of my comprehension of water. To explain this ticking, which is quite strong with water, you need quantum physics. If you don't have quantum physics, you cannot explain why water is so sticky. Then, when I realized that water was a very sticky or cohesive substance, I wonder, is there in the universe a substance that is more cohesive than water, relative to its number of electrons? Because, of course, if you have a big number of electrons, it will be sticky, as I explained you before. But we will take small molecules with small number of electrons. And there is a good candidate, it is hydrogen fluoride. Because hydrogen fluoride, it's fluorine, 9 electrons, and 1 hydrogen, 1, 9 plus 1 equals 10, like water or methane. Well, when you make the calculation, this is technical, we don't explain how we can get a classification according to cohesive energy. We see that water is more cohesive than hydrogen fluoride. More. In fact, this makes sense. Why? Because when you say hydrogen fluoride and you want to make an hydrogen bond, you have just one possibility. Because in hydrogen fluoride you have 1 hydrogen. But in water you have 2. So even if intrinsically the bond is stronger with hydrogen fluoride, as you have only 1 but 2 with water, it's water which will win. Because that's 2. And 2 is larger than 1. And if you go back to ammonia, N, nitrogen and 3 hydrogen, 7 plus 3 equals 10, then again you get a gas. So, methane, ammonia, hydrogen fluoride, 10 electrons, they are all gas. Water, 10 electrons, liquid. And I try to find a substance that were more cohesive than water, and I don't find it. In other words, I think that water is the most cohesive substance of the universe. That is to say, for a given number of electrons, if you want to get the stronger bond, not covalent bond, but what we call hydrogen bond, it is with water. And now it began to make sense because water is the most cohesive substance of the universe, and it is the most abundant. Why life would use another substance than water? Because with water you have the most probable substance that you will meet anywhere in the universe, and it will give the stronger bonds between molecules. It's perfect for biology and life. You cannot dream of a better substance. You have it. it's water. So this is the point. With water, we have 20 zeptojoules of bonding, of sticking, and this gives rise to what is, for instance, when you look at, we forget water, we just look at what is in biological textbooks. They call these proteins. Proteins are very important for life because they give structure and functions that you don't have, of course, in a glass of water. So that's why we go to proteins. But proteins use hydrogen bonds for making shapes, enzyme. If you go to the DNA is full of water, and the double helix use this hydrogen bonding for making the double helix. So we see this interaction between hydrogen and oxygen. We see it everywhere in biology. It is not only in water, because the key point is that it is not water, in fact, which is important. It is the fact to have hydrogen and oxygen, which give rise to very strong bonding. Even if this oxygen is not bonded only to hydrogen, but to carbon, or to nitrogen, or to another element. The only fact that you have an OH bond will give you this magical cohesive energy, which is in the combination between hydrogen and oxygen. And of course, this combination is maximized in water when you use type 2 hydrogen for 1 atom of oxygen. So we have this, this is a chemical evidence. This has nothing to do with biology. The abundance comes from the cosmos, and the bonding comes from both come from quantum physics, in fact. It is to say, if you use the quantum physics rules, you explain very easily why water should be the most abundant and the most cohesive substance of the universe. That's okay?
I've got a question, because water, the way it is integrated in life on the planet Earth, it could happen due to certain circumstances on the planet. Now, if you take 1 milliliter of water or a drop of water, let's take just a drop of water, and we release it in the intergalactic space.
Yes, it will vaporize.
It will vaporize.
What is breaks the bond?
The bonds are breaking. So what's happening? Why is that happening?
Yes, this is a very good question, but I think that the answer will not make very happy some bodies.
So what's your explanation?
It's a very subtle point. In fact, it is linked to entropy. When I spoke just a few minutes before, I spoke of energy in zeptojoule. And I told you that in the air you have 4, that the bond between hydrogen and oxygen, the covalent, is 1,000, and the bond between 2 water molecules is 20. These are very important numbers that you should remember. Because when we will speak about the energy in the vacuum, we'll get numbers also. Just keep in mind these numbers. But this is energy. This is not entropy. And as I told you yesterday, nature works with entropy, not energy. That means that, what does that mean to have a bond energy of 20 zeptojoules between 2 water molecules? In fact, it is because we are on Earth. And the point is subtle. In fact, the bond does not exist. There is no bond. What makes the bond, what makes the 20 zeptojoules, is that we are on Earth. In other words, what you could say, that a water molecule cannot escape in space. Why? Because its molecular weight is 18 grams for 1 mole. And we know that with such a molecular weight, the probability of escaping the gravitational field of the planet is very low. Of course, you have some molecules which evaporate, but the Earth has a mass which is strong, which is large enough to keep the water in the atmosphere. And this is the real point of a chemical bond. A chemical bond exists because you are in a beaker.
So the container is planet Earth.
Yeah. We don't realize that the Earth has a play to role in chemical bonding because it's so big, the molecule is so small, that we think that the bonding exists as a consequence of the atom. No, the bonding exists as a consequence of the Earth. And we can very easily understand this because you just take me the example. If I take one drop of water on Earth, it is a liquid, 20 zeptojoules. But if I put it in the vacuum outside from Earth, no more liquid. The same drop, the same energy, but now it dissociates into a gas. That means if the dissociation occurs into a gas, that means that there is no more bonds. And so the bonding is not the consequence of being of electrons which interact among them. It's electrons which interact among them on Earth in a gravitational field. Because if you remove the gravitational field, if you go to the vacuum, the empty space, you have no liquid. The only thing you can have is solids. But even solids does not exist. Why solids exist in the outer space? Because you have planets, you have meteorites, asteroids, and these are made of solids. Mainly amorphous ice. Water, in fact. But that's another point. But they are solids. Now you have the key. They are solid because they are in the solar system. When you say I am out of Earth, I am in the vacuum, but in the solar system. And now it is the mass of the sun which prevents the dissociation. If I leave the solar system, it becomes complicated because it's very difficult to leave the solar system because it's very big. But we try to imagine that we take our drop of water. No, or solid. Maybe I would say diamond, which is one. Diamond. You put diamond very far from any mass, it will vaporize. Because there is no more a gravitational field to get a confinement. So this is why you cannot speak about energy. It's a crazy thing. Or if you want to speak of energy, you must refer to the container. We have bonding energy on Earth because we are on Earth. If we go to other gravitational fields, what we call chemical bonds may exist or not. In other words, chemical bonds exist because of the container. And of course, when you are on Earth, it makes sense of speaking of energy. Because I am on Earth. And on Earth, as a living being which lives on Earth, 4 zeptojoules, 20 zeptojoules, 1,000 zeptojoules has a meaning. But because we are, I don't say how we call terrien, inhabitant of Earth, terrien. If we were at the thousands of light years of distance, the picture could be completely different. And so we are at this point where energy, in fact, is not a reality. But now if we take entropy, the things become obvious. Why a solid should dissociate when there is no gravitational field? But just because a gas has a higher entropy than a liquid, and a liquid has a higher entropy than a solid. And we have the second law, which states that if you take a very big volume, of course, the things will dissociate because a gas has always a larger entropy than a solid. And this is a consequence of the volume. If you take a teeny volume, you can have solids and liquids. And a teeny volume is what we call Earth. If you think about Earth, for Earth it's a big volume, the atmosphere. But in fact it's very small relative to 40... this light year unit is crazy. I would say 10 to the power 26 meter, which is the size of the universe. The Earth is not 10 to the power 26 meter. So we are on a teeny spot. And because we are on the teeny spot, we can deal with energy, not with entropy. But if we take again the scale of the universe, there is no more energy disappear because it's a concept which is very hard to define. We get only the single concept, which is entropy, which explains that everything should be a gas. And that's a reality in the universe. At the scale of the universe, there is only gases, because these are states of maximum entropy.
So the hydrogen bonds are a terrestrial, or according to the planet circumstances, phenomena.
I don't
So the hydrogen bonds are a phenomena we observe because we have certain conditions on the planet.
Yes, we are on a planet with an atmosphere which gives an ambient pressure of 1 atmosphere, 10 to the power 5 Pascal. And these numbers, this energy, are always referring to the Earth. If we change the planet, we will get other numbers.
So this joins what you said before about the history of science and the fossil concepts, because we need a starting point, and we started investigating water on this planet, and at some point we might go further and study other circumstances, and we might discover other phenomena. Now, what are other mysteries of water? You mentioned a few.
This is the most... in fact, there are other mysteries, of course, but they all derive from this basic cohesive energy, which is too strong relative to the number of electrons.
So how do you explain that, finally?
Well, after it's a technical consideration. We have to go into sordid details such as its capacity, density. For instance, we have this very well-known phenomenon which makes how we call plombier in English?
Plumber.
Plumber? Mm-hmm. Water makes a lot of money for plumbers. Because when you forget to cut alimentation in water in your canalization and the temperature drops below 0 Celsius, mm-hmm. What you get ice, which has a larger volume than liquid water. And so the canalization will break. And the plumber say, wow, there are money to make because you have to repair. And this is another strange point. Because when you think in terms of energy, because we are on Earth, so we can use energy and everybody uses, I say that temperature measures the average kinetic energy of a molecule, whether it is in the solid, liquid, or a gas. It's always its average kinetic energy, which is given by the vacuum. Okay, so now you change the temperature. That means if you go at lower temperature, you will have less kinetic energy. If you go at higher temperature, you will have more kinetic energy. And what does that mean, having more kinetic energy? That means that you can explore a larger volume. than at lower temperature. This is called, with liquid or solid, it's called dilatation. It's to say you have a certain volume at a given temperature, you increase the temperature and you increase the volume. You decrease the temperature and the volume decrease because you have less kinetic energy. But with water, it doesn't work like this. With water, if you have above 4 Celsius, you have an increase of volume when you increase the temperature. But if you go below 4 Celsius, it is the reverse. It is to say you have less energy and more volume. Very strange. How I can explore a larger volume if I have less energy? And of course, it is very amazing because if we are very pure water, if we are able to have very pure water, the freezing point is not 0 Celsius, but minus 42. That is to say, you can go to minus 42 Celsius by staying a liquid. And ice appears only at below minus 42 Celsius. But it is for very pure water. And now, between minus 42 and 4 Celsius, the less energy you have, the larger the volume. Try to explain this. The only explanation, this phenomenon was known by Galileo for 4 centuries ago. And even now, in physics, it's very difficult to explain why this is so. And if you think it's a very important behavior of water, because if water will not increase in volume by lowering the temperature, at low temperature you will get ice from everywhere in water. But not with real water, as we know it. Ice forms only at the surface, never at the bottom. That means that you can have very low temperature and still liquid water, provided that you have an ice core, which prevents the temperature to go below 0 Celsius. Another way of saying that, if you take a thermometer and make diving, you will always get the same temperature everywhere on the Earth, 4 Celsius at the bottom of any large amount of water. Because it is the point where the density is maximum. And you have Archimedes' law, which says that if you have two fluids, one which is dense, the other which is less dense, if you start like this, the more dense will always be at the bottom, and the lighter one will be at the top. And 4 Celsius is the point where water has the highest density. So when you are at 4 Celsius, water, the only possibility for water is to sink. And so the bottom of the ocean are always at 4 Celsius. Even if in the air it can be minus 70 Celsius, because you are at the North Pole or at the South Pole. Deep inside the water, we have 4 Celsius. Again, a very strange thing that cannot be explained by classical physics, or easily by concepts such as I increase the temperature, so I increase the volume. So this is so obvious for water, it doesn't work like this. And this is another mystery, which is a consequence of the fact that water is the most cohesive substance of the universe. This is also not something which is strange. But in fact, when you go to quantum physics, you see that all these strangeness are very easily explained. This is the consequence of what is called coherence domain. That is to say, in quantum physics, you just say, okay, I have matter, but I have also vacuum. And when you take into account the fact that all the things that are around you are made of vacuum and matter, now these mysteries disappear. Because in fact, these mysteries come from the vacuum. The things that you have evacuated when you think matter, you remove vacuum, because the definition of a vacuum is to have no matter. And we have the idea that vacuum is nothing. But if you go to quantum physics, vacuum is something. And if it is something, you have to take into account for speaking of water. And when you take into account the fact that water is full of vacuum, that a cell is full of vacuum, that you are full of vacuum, now you have no more mystery. You explain why ice floats on water, and you explain why water is the most cohesive substance of the universe. It's become clear.
Can you explain us, please, what you understand by coherent domain?
I speak a little bit about this subject yesterday, when I told you that you have coherence in space, coherence in time. I forget to talk about coherence in mass. And in fact, that the new way of thinking in physics is not to speak about things, but about coherence. That is to say, in fact, this is a revolution. Instead of saying, I have an object, the object doesn't matter. What it is interesting in physics is when I have two objects. Because when I have one, I can only interact with myself or with the vacuum. Not very interesting. But when I have two objects of the same nature, then they can interact each other. And quantum physics is the science of the interaction, not of the object. No matter what are the objects. What is important in quantum physics is their interaction. And if you go at the highest level of quantum physics, we learn that what interact, in fact, are fields, which are immaterial things. And when fields interact, they create particles. So here we understand why Poincaré was saying at the very beginning of the 20th century that matter doesn't exist. Because matter is created by the field. And if the field creates matter, matter doesn't matter. Matter doesn't matter. Maybe I am an Englishman after all. Because I am even able to make jokes in English. That's amazing. That's another point. So, okay. So we have this point. And we have a trouble with quantum physics because you don't meet quantum physics in the high school. In the high school, we teach fossil concept. Newton's law, crazy things that energy exists independently of the container.
Entropy is disorder.
Entropy is disorder. So you learn this in high school. And when you begin to hear about quantum physics, it's usually at the university level. At the university level, teachers say, well, we have been lying all along. And so now we need to tell the real truth. Classical physics is an heresy. You should go to quantum physics. And now came the problem. Because when you go to quantum physics, I have teachers of quantum physics or quantum mechanics, maybe mechanics and physics. It was then formula everywhere. Formula and formula. Equations.
So when you talk about quantum physics, you refer to quantum mechanics, basically.
Quantum mechanics, yeah. What we usually learn in university is quantum mechanics. And the teacher, instead of saying that quantum mechanics or quantum physics is a very basis for the water properties, he began to write equations on the blackboard. And you have to learn how to solve these equations. But solving an equation has no link with the compression. Why is such an equation? And we have a very good example in science where people never solve equations. They know the solutions. And when you know the solution, You make computation to check that your solution was a good one. You don't make computation for just making computation. And this is a problem with quantum mechanics, that it is always associated to computation, formula, mathematics. And as you know, because you are a great mathematician, Klaus, if I begin to write equation on equation, you just say, sorry, I have other things to do. I have no time of spare by trying to solve equation. And you say, this could be important, but this is not for me. And you are not the only one. Most people, when they are heard about quantum mechanics from the mathematical point of view, they just say, no, that's not for me. And if you say that, that means that water is not for you, as you are made of water. It is to say, you are negating yourself. This is the beginning of big troubles, because you want to understand who you are. You want to understand water, and you have to go to quantum mechanics. Because if you stay at what you learn in school, you will never understand water, and you will never understand who you are. So you see, we are at a very crucial point. We really need to explain what is quantum mechanics. Not from a mathematical point of view, but from a philosophical point of view, from just trying to give answer why I am here and made of water. You need this knowledge. And you, and of course, physicians also need that. And now, for me, it's very easy because I have considered all the mathematical details. I have solved all the equations. It was a crazy thing. But I've done that. And then when after solving all this equation, I say, well, okay, now, what is the words? You say, oh, we can speak about this science without going into the mathematical details. And in fact, it was rather simple. When we want to explain what is quantum physics, first, it is physics where vacuum is a thing. Vacuum is not nothing. Vacuum is a substance. And this is the reason why now in my conference and my books, I don't use the word vacuum, because vacuum, you always think nothing. And if you want to speak of vacuum as being something, this is not the good word. We should use another word. And this, I refer to general relativity, because in general relativity, Albert Einstein was very clear on this point. In the 19th century, for explaining how light propagates in the vacuum, physicists were speaking of an ether. Say there was an ether which was vibrating, and it is the vibration of this ether which allow light to propagate into a vacuum. And then he analyzed a very famous experiment, which is the Michelson-Morley experiment, and he came to the conclusion that in fact, ether doesn't exist. It cannot exist. Otherwise, if ether was a substance, we will get some interference pattern on the device, of the Michelson-Morley device. And as we see no interference pattern, the consequence that there was no ether. Well, that was in 1905. He made a very famous publication where he said, ether doesn't exist, exists only vacuum, and there is no propagating medium. But he was very clever enough to call this theory, where ether was negated, doesn't exist, he called spatial relativity. He don't speak about relativity, but he says this is spatial relativity. And as you know, if you add spatial, that means that you doesn't cover all the cases. You are interested in a special case. And this special case was the movement at constant speed. That you say all he was saying about ether apply to movement at constant speed, not accelerated movement. And of course, just after his publication, he scratched his head. Why I should limit myself to special relativity? What I cannot speak about accelerated movement, because acceleration is everywhere. In the universe, on Earth, we are always in front of speeds that are changing with time. So, accelerated movement. And so he scratched his head for 10 years, and then he make general relativity. And of course, when you move to special relativity, to general relativity, now you have a much wider view. And a special case, which is special relativity. And then, when he go to general relativity, he say, oops, and ether exists. He was obliged to reput the concept of ether because it was at the very heart of general relativity. Why? Because in general relativity, Einstein has understood that we have a phenomenon which is very strange, which is gravitation. What is gravitation? Why two masses should attract each other? This is, again, a fossil concept. It's crazy. By which mechanisms two masses that are billion of kilometers apart feel that they are there? It's crazy. Fossil concept. Action at distance. We should put this into the placard. And of course, when you say we can no more speak about action at distance, but we should speak of something because gravitation is a reality. And now you realize that space, empty space, vacuum, was a substance. A substance that you can bend. Because this is a property of a substance, you can give it a shape. Or what is called a curvature. Instead, in special relativity, the idea was the vacuum was flat, no curvature. But then you realize that, in fact, vacuum is not vacuum, it's ether. It's a substance, which is called ether, that you can bend. You can curve the vacuum. Oh, if you curve the vacuum, maybe the vacuum is something. And this is why, in a conference in 1921, he said, sorry, I make a mistake in 1905. I say that the ether doesn't exist, but this was a mistake because I was just considering special relativity. When you move to general relativity, ether exists. And he was even writing much a stronger argument. A space without an ether is not conceivable. We cannot conceive a space not filled with an ether. And of course, for me, it's a very good point because instead of speaking of the quantum vacuum, which gives to the people the idea that there is nothing, we can speak of the ether. And in the ether is the thing, that means that you have energy, you have information, you have things like this. So this is why now I use the term ether, because it's a much more satisfying term, and it has also a big advantage because this term is not unknown. It is explicitly stated in Greek philosophy, the ether exists, and in Hinduist philosophy, it's called Akasha, and in Chinese philosophy, it's called Tao. So, so this is very nice that we can get a term where everybody agree, which is Chinese, Indian, or European. So this means that in fact, we have two basic substance, two basic things in the universe. We have ether, and when ether undergoes vibration, it creates matter. Because ether is a field, in fact, and this field can create particles by vibrating. This is quantum mechanics or quantum physics. That is to say, you move the reality not from what you observe, you move the reality to the fields, which fill a substance which is called an ether. And when these fields vibrate in the ether, you get particles that we call matter. This is the modern knowledge, and this is this kind of thing that you should learn at school. We are the consequences of interacting fields, which are not material things, but which are vibration of an ether. Clear enough?
Yes, thank you. Can we try to go back to the coherent domains?
Oh, yeah. Yeah, of course, yeah. So now that you see, you know that water is a field, not a molecule. Water is not made of atoms. In quantum physics, there are fields that are vibrating and creating the things that we call hydrogen, the things that we call oxygen, which are not bullets. This is not teeny balls. This is a fossil concept. We are all vibrating fields. Not, of course, this ether is filled of energy, is filled with energy. This is another consequence of quantum physics, and this is the very basis. You have an undetermination relationship. That to say, the new point in quantum physics relative to classical physics is that in classical physics you can measure everything with all the accuracy that you want. If you want 1,000 numbers after the dot, it's okay, you will get them. Just a matter of time and technique. But in quantum physics, it's no more a matter of time and technique. You are limited in your knowledge by undetermination. Another way to say is that in quantum physics, we should work with probabilities and not with realities. We have to go to probabilities. And if you have to go to probabilities, a thing may be here, or maybe not. It is to say, you are never sure that something is somewhere. It could be there, or it could be elsewhere. We have a spreading of the object, of the point. No more point, we have object, we have a volume in the space, in the time. And there are rules for this volume, for this spreading of energy. We can spread the energy in a given amount of space. We can spread this energy among a given amount of time, because we live in a space-time, 4D continuum. And here are the very basis and uncertainty relationships of Heisenberg, which are the art of the coherence domains notion, is that if you know very well the energy, very accurately, you cannot know the time. You say you have a big undetermination on the time where you are getting this value. Or if you go very deep in the accuracy of localization in space, you will lose the accuracy on the speed. These are what is called conjugate variables. That is to say, if you know very accurately one, the other one is unknown. And if you know the other one, it is the first one which is not known. It cannot be known. There is a forbidden. You cannot go beyond a given accuracy, which is fixed by the Planck constant. It is the constant because it is not zero, it's very small, but it's not zero. So as it is not zero, you cannot measure simultaneously the position and the spin, simultaneously the time and the energy. And when you go to fields, there is no more time, there is no space, you still get an undetermination relationship between the number of particles and what is called their phase. The phase is an angle. That is to say, if you want to know this angle, you cannot know the number of particles. If you know the number of particles, you cannot know the phase. And this becomes very interesting. Why? Because when you take this Lat uncertainty relationship, which is for the fields, not for the matter, energy, or speed, when you take this fundamental equation of quantum field theory, because we ajoute field to quantum field theory, the factor which drives the product of the two uncertainties in the number of particles and the phase angle is not the Planck constant. It's 1/2, a pure number. Because when you say the number of particles, that is as no unit. This is the number. When you say a phase angle, an angle has no unit. Because when you define an angle, it is the ratio of two lengths. So you have a product of two things that have no dimension, number of particles, angle of phase, and you have something which cannot be zero, but it should be also without dimension to keep coherence. And the number is very simple, it's 1/2, 0.5. And now we have a new thing that appears, it is scale invariance. Because 1/2 will always be 1/2. Whether you are an atom, a quark, or a galaxy. 1/2 is the same for a galaxy or a quark. That means that quantum physics is not a physics of small things. It's a physics of everything, big or small. And again, this is a fossil concept that we meet in quantum physics. The fossil idea that quantum physics is okay for small systems. But as soon as you move to large systems, it's no more quantum physics, it's classical physics which applies. No, this is a fossil idea. Wrong. You should be quantum from the smallest volume to the largest one. And this is very difficult for physicists to understand that quantum physics is a scale invariant science. It applies at any scale. And it is now, when you have this background, that there is an ether, and we have this undetermination of Heisenberg between the number of quanta and the phase angle, or between the energy and the time, or between the speed and the position. We have to take this into account. And there is a very beautiful way of doing this. You take the Planck constant. What is the Planck constant? It's an energy times a time. Joule second times second. And now I will multiply the Planck constant by the speed of light in the vacuum or in the ether, which is a constant like the Planck, another constant. But now I take something which is joule times time, difficult in English, times time, multiply by time, and I will multiply by a speed which is length divided by time. And when I multiply the Planck constant by the speed of light, I get an energy times a length. Joule meter. And now, it's very nice. Because what I have is a length. If I know the length, I will know what kind of energy I can get for this length. And I will speak of a length of vacuum, or ether. And as the Planck constant and the speed of light are very well known, constant, which are known with very high accuracy, I can give you the number. Here, for the single time I will take a paper not to say, the product is 16 zeptojoule, 16 zeptojoule micron. We see again appear the zeptojoule. That's why I insist before on zeptojoule, because here we have 16 zeptojoule for 1 micron or length. 1 micron, it's 10 to the minus 6 meter. It's small, but not so small. 1 micron, it's just the limit of an optical microscope, so it's okay. Or if you prefer, just the wavelength of red light, which is about 1 micron. That means that if you just take a small volume which has a size of 1 micrometer in size, you will get 16 zeptojoule. As I told you before, if I take the electricity, the electrical interaction between two water molecules, I get 4 at most. And I told you that the hydrogen bond was 20. But now you understand why 20, because you have the 4 for the classical interaction between positive and negative charge, and you have 16 from the vacuum. For a given size of 1 micrometer. That means that if you have something which has 1 micrometer in size, you will get roughly 20 zeptojoule of energy, of bonding. And now you explain what is water, and the consequence is that when you try to apply this not to one water molecule, but to a big amount of water molecules, as you have a limited, if you are limited in space, and I will not go into the detail, but the wavelength that can be extracted from the vacuum is 100 nanometers, 0.1 micron. You will have energy from this. The water molecule will become excited. With this energy, we come from the ether, which is its internal ether, will give it energy to make a self-excitation.
So this means, this means that the whole body is basically becoming a surface of excitation.
Yeah, always. Matter is always a vibration. It's not matter, it's ether which undergo vibration. So let me finish. So now you take into account the fact that the water molecule can change in energy by exciting itself from the ether, which is inside. The excitation doesn't come from the outside, it comes from the inside of water. And of course, when you excite water, what the consequence is that you go to an upper energy level, and the water molecule becomes bigger. Bigger molecule, bigger volume, so decrease in density. That is to say, if you want that something increase in volume by decreasing the temperature, all you have to say is that instead of being perturbed by the exterior, you give the opportunity to the molecule to speak with this interior. And as a consequence, it becomes bigger, larger volume. And as you have a larger volume, the density decreases. And that's what you observe. And that's why plumber makes money. But it's always to make a link between very fundamental things and very common things. Plumbers makes money because the water molecules becomes bigger when the temperature is lower. And this comes from the idea that quantum physics is a quantum vacuum is an ether substance. So you see and now, when you say this excitation, of course, it is because at a temperature means that other molecules will break this excitation from the internal vacuum. And now you have in fact competition between two things. I have excitation from myself, from my internal structure in terms of ether, and I have excitation from the outside, which we call temperature. And of course, at a given temperature, I will have what we call a coherence domain. That is to say, this interaction from my internal vacuum can propagate on a volume, but it doesn't remain on a single molecule because it is electromagnetism, it propagates, but it cannot propagate very far. And the key point is that it is about 100 nanometer. So what does that mean? That means that when you look at water, you should not look water as made of water molecules. First, because matter doesn't exist. These are fields. There is no hydrogen, there is no oxygen, in fact. You have just electrons, quarks, and basic component of field which are created and annihilated by the field at any time, very quickly. And as this is very quick, seems that these objects are permanent. But in fact they are not. They are always created and destroyed, created, destroyed, created, destroyed at any time, very fast. And when we solve the equation by summing all the information, we find 100 nanometer. That means that you should look water as made of coherent entities or incoherent entities, because you are not obliged to go to coherence. And this coherence, we call domain, coherent domain, and they are a size of about 100 nanometer. Or if you prefer, if you take water, and if you have something in water which is not water, you will create an interface, because you have water and something which is not water. For instance, for a living body, this interface is a membrane, the lipidic membrane. This is oil. You have polar heads, and these polar heads are covered with water in the intracellular medium and the extracellular medium. So on this polar head you have water, and this water should not be considered as water molecules, but as coherence domain of 10 million water molecules. This is the amount of water molecules you have in a volume which is 10 nanometers times 10 nanometers, 100 nanometers times 100 nanometers times 1 nanometer in the third dimension. It's about 10 million water molecules. And this is the entity that we deal with biology and medicine. We don't deal with water molecules, we deal with coherence domain. And coherence domain, as it is 10 million of water molecules, this 10 million of water molecules can be in two states. It can be in a state where they are full quantum coherence, that is, they all have the same phase angle. They vibrate with the same phase angle. And also this means that it is just, in fact, they behave as a large molecule, the polymer. They behave as a polymer. Or they can be in an incoherent state, that is to say that these 10 millions of molecules have not the same phase angle. And as they have not the same angle, here you have 10 million of water molecules. and not a single entity. Quantum entity, you have the usual way of seeing what is a liquid for a physicist. It is to say, objects which are moving everywhere within an incoherent state. And now we have a critical point, because when you have coherence, the 10 million of water molecules cannot be separated. You should consider them as a block. And this would be a first state. You will have a possibility to have another state when you destroy the quantum coherence, and you will get, instead of one block, you will get 10 million of smaller blocks that we call molecules. And this is another state. In other way, water becomes a system which can exist under two states: coherence, incoherence. And if you have made a little bit of informatics, the basic point for having a memory is to have a system which can exist under two states. At the first state, you will associate the bit 1. At the second state, you will associate the bit 0. And as we know from the Boole's theorems, anything in nature can be reduced to a series of 0 and 1. This is called binary language. That means that you can encode information on your membranes. Or, as one very nicely shown by Jacques Benveniste and Luc Montagnier, water has a memory. But be clear, this is not pure water which has a memory, because you need to have something which is not water to get these coherence domains. There should be on something which is not water, because if you try to do this in water itself, it doesn't work. There are too much repulsion between the electrons.
That's why the membranes are so important.
Yeah, that's what is important, to have a membrane. Or if you are in a liquid, your water bottle, here it's the nano drops of gas which plays the role of the interface. That is to say, it is critical to have gas in the water. Mm-hmm. And this is, in fact, always satisfied, because we are on Earth, and our water is always in contact with the atmosphere, which is full of nitrogen, oxygen, carbon dioxide. So we are full of gas in water. But the experiments have been done. If you just remove the gas, you will have no more water memory effect, because the memory effect is at the interface between the gas and the water. It is not in the water itself. So we can speak about water memory. This is a good concept. And this is the reason why I want to be, again, clear. I don't speak about water memory, because water by itself cannot have a memory. I speak of morphogenic water memory. That is to say, I speak of a water which contains something. And when water contains something, I call it morphogenic water. Why? Because if you have made Greek, morphos is the shape, and genos is I create the shape. And this is something that you can easily understand. If you take a carrot, it has a shape, but remove the water, there will be no more shape. You will get powder. You see? Yeah. So if you have a shape in the nature, it is because the things are full of water. And you have information in this water. And it is this information in water which gives the shape. And if you remove the water, no more shape. This is called what I call morphogenic water. And now there is no trouble, because when you take the precaution to add morphogenic, you understand that you don't speak of pure water, but some water which contains something. And now everything becomes clear, because physicists are right. Pure water cannot have a memory. This can be demonstrated by the equation. In order to stabilize this mechanism of memory of water, you need something which is not water. For a cell, it is the membranes. For the liquid water, it's the gas, which is dissolved inside the liquid. And it can be also another liquid, for example, for mayonnaise. It's an emulsion, so you can also have liquid on liquid, oil. And as soon as you have something which is not water and water, you will get coherence domains and you can store information.
So, Professor Marc Henry, we have certain conditions like a lipid double layer membrane. Water molecules can organize in a certain way and can build coherent domains. Is it then possible to create resonance with these coherent domains?
Well, of course, because the mechanism...
And what would be the consequence?
No, the mechanism which gives rise to the existence of coherent domain is electromagnetism. That is to say, you extract from the vacuum, from the ether photon, and I can give you the wavelengths. It's ultraviolet photons. And by sharing this photon between 10 million of water molecules, you store an infrared radiation. That is to say, you should consider the coherence domain as made of water, vacuum, and light. And more precisely, infrared light about 10 micron in wavelength. So when you have this, light has the property that it can propagate. So what happens in the coherence domain, it acts as the infrared light is trapped, cannot escape. But you can send light from the outside. And of course, light from the outside will interfere with the light from the inside. And this is where you can use phototherapy, for instance, by infrared. It works very nice. You have people who are sending device, we create infrared, and you will get less pain. You can solve problem by just irradiating the body with infrared. And you have also a very good source of infrared. It's your hands. Mm-hmm. So when you see people which comes and puts the hands on somebody which is ill, he sends infrared. And as the coherence domains are made in part of infrared, you have an interference. So you can heal somebody by putting your hands on the skin. This is not magic. This is just physics. Quantum physics allows you to do that. So now after, you have just to be clever enough or to make a perturbation. And the idea is to maybe to see that in your membrane you have an information which is encoded, which makes you ill. The illness comes from the information in the water, not from the matter, biological matter. Not the biological matter which is ill. It is a bad information which is written on your membranes. Mm-hmm. And this is the reason why if you use what we call an information healing technique and not a chemical, a drug, if you put a drug, you will act at the both level, at the level of the information which is on the membrane, but also you will interact with all the biological machinery which is inside the cell. And so you can make what is called effets secondaires, side effects. Mm-hmm. The idea is not to use a chemical or a drug, it's to use pure information to change the information which is stored on this membrane. Here you have a 1, this 1 should become a 0. Here you have a 0, it should become 1. And you should not do that only 2 times, but many amount of times. And here we have a very beautiful way of doing that, is resonance. That is to say, we know by the physics of resonance that if two systems have a common frequency, because they are vibrating, and as I told you, matter doesn't exist, it is always vibration of ether. This is the basis. If two phenomena have share the same frequency of vibration, then something can pass from one system to another. And it is very important because you have also amplification. You say even if the source signal is very small, you can have a very large effect. And now this means that small is not nothing. If you have resonance, small can be big. And here you get a very well-known healing technique, which is homeopathy. In homeopathy, you use infinitely small things to get very large signal because you have amplification and resonance. And this amplification, for those who want to understand this phenomenon, is very well known. You take a glass where you put water or wine. It is a solid, and it is very strong. But if you are able to sing a certain note at a given frequency which corresponds to the basic frequency of vibration of your glass, what will be the consequence? Because the sound vibration is teeny relative to the cohesive energy of the glass. It's infinitely small, but the glass will break because of resonance and amplification. And this is the very basis of this new technique of healing based on information and water, and not on drugs, is that you work by resonance and amplification. And as we know, amplification is a basic phenomenon of nature. We have amplificator for everything. We can amplify light, we can amplify sound, we can amplify everything. The only requirement for being able to amplify is to have non-linear phenomenon. Because if you are on the linear phenomenon, there will never be amplification. And so the key point is a cell a non-linear system? And of course the response is yes. And as the cell is a non-linear system, you can work with amplification, and even very small amount of energy of information could have a large effect by resonance.
So we're getting very technical, but for me, I would love to understand better how we can, through resonance and amplification, increase entropy.
Well, because entropy, it is very easy to compute entropy. What is the vibration?
Mm-hmm.
What is amplification by resonance?
Yeah.
You see?
Yeah.
The difference? When I have my normal state, no resonance, then another frequency comes which are in coherence with my frequency, and then the vibration, you get a larger volume. What you call the matter can go in other place than when you are making your standard movement. But being able to go to place that was not allowed before is increasing entropy. So as soon as you make a resonance phenomenon, you increase entropy. And you can do that in terms of position because it's easy to visualize. You can also do that in terms of speed. Because don't forget that in entropy you have position and speed. And so the resonance phenomenon is always an increase in entropy. You increase the entropy flux. If you have an entropy flux, by resonance, this entropy flux increases, and more entropy flux means more complexity. You can deblock entropy which was blocked somewhere. So it's very clear, there is no additional hypothesis. All you have to understand, entropy measure my ability to go farther in space and farther in speed.
I still do not understand the mechanics behind.
There is no mechanics. Because you want to have a mechanics, matter doesn't exist. So please forget about mechanics. Mechanics have to do with material things that move. We are speaking of things that vibrate. Vibration. So there is no mechanical explanation. You will never find a mechanical explanation.
If you create resonance with coherent domains, you impact the information on the coherent domains.
You can change by resonance the information which is encoded on coherent domain.
How does that translate in an entropy flux?
Because
that's where I have the
when you have resonance, I told you, you have an increase, a temporal, a momentarily increase in entropy flux, so you can deblock things that were blocked. And then after, you go back, but you have another state. Another information has been encoded and things behave differently. I cannot tell you more than that. You are ill. In terms of entropy, that means that entropy is not evacuated somewhere, as it should be. By resonance, you increase the flux. So it is like when you have a river which is flowing. We know we can make dams on rivers. Okay? Mm-hmm. And even if you are a kid, you do that. You have a river, and they take stones, and they try to stop the flow. Of course, they cannot, because you have to make a dam. The flow will go over the dam by the side, and you have to make stones all along. But even if you do that, if there is a rain which is falling, and an increase in the flux of water, the dam will be break. And after the flow, you will get again a natural flow, but the dam has disappeared. So people will be ill. It is not much complicated than that. You have a dam, you increase momentarily the entropy flow to be able to overcome this dam. And more ideally, not to overcome, but to overcome and break it. Mm-hmm. When we go back to previous condition where you have no resonance, you have the same entropic flux because you have your metabolism, but now the entropy is no more blocked. And you say that the people have been healed. Mm-hmm. But I cannot give you more details.
Yeah, still there is something mystery about
the
mysterious about resonance.
Yes, because we cannot imagine. We always try to make matter where there is no matter. So resonance is not a material effect. And the mystery is because we try to make a mechanical model of resonance. Mm-hmm. There is no mechanical model of resonance. It is a basic property of nature. And in fact, it is very, very common. Resonance, we call it music. Mm-hmm. When you have music, it's resonance between your ear and air, which is vibrating. Mm-hmm. And you call this music, but music is fundamental. You cannot imagine a world without music, because resonance is everywhere, even if we don't use the word resonance for music. And this is in my book, I call this the sixth way of thinking, mm-hmm. musicalism. They are forgetting about mass, matter, we don't care about this, just we have vibration, frequencies, resonance and music. Everything in the universe is music. And when you are at this level, if you try to re-put your old fossil concept of matter, because matter is a fossil concept that should be discarded from science, when you try to re-put this fossil concept, I don't understand. No, you don't want to understand, because you stick to an old fossil concept which is called matter. You should adopt the new one, which is vibration. Mm-hmm. And vibration of what? Of ether, of vacuum. This is a new way of thinking. And when you have this new way of thinking, it is quite coherent, quite logic. Don't try to give explanation in terms of the old of a system which is not related to vibrations. This is the role of the Planck constant, the sixth constant, universal constant of physics. It is an energy times multiplied by a time. And what is a frequency? It's the inverse of the time. So when you get a frequency and you multiply by the Planck constant, you get an energy. And when you divide this energy, you take that energy is at a given temperature. So you divide by the temperature, you get entropy. Mm-hmm. And you should not forget to divide the energy which doesn't exist, which is a fossil concept, divide the energy by temperature to get the real thing of nature, which is entropy. Joule per Kelvin. All you have to do is think in this way and forget the old way of thinking. So when you are now a physician, you have somebody which is ill that you want to heal, and you just have to say, wow, what is a good vibration, what is a good information that I give you to this man or this woman. And if you give the information, if it is in resonance with all the information which is in the body and the membrane, you will get the person will no more be ill. I will not explain this to you. We are doing this in Africa.
I do. I do. One of the ideas of talking with Professor Marc Henry is to understand better the clinical phenomena I observe in Africa when treating epidemic disease and trauma. So I try to give this rationale, and the by far best academic I could find is Professor Marc Henry. So quantum mechanics is very clear about energy and talking about septojoule then.
Yeah, if you have to be clear that if you want to speak about energy, you have this energy which is a septojoule for life. It is a good unit for life, for molecules, water. Yeah. But don't forget that this always refers to the Earth.
Earth conditions.
Yeah. It is to say,
terrestrial conditions.
If you are on other planets, energy will be completely different because the container is not the same.
So they must have noticed that up there in
because
space.
With entropy, the amount of entropy will be always be the same, whatever the container, but not the energy.
So they noticed that up in space.
Yeah.
The cosmonauts know that. They learned about all that.
Yeah, of course. But not only the cosmonauts should know this. Everybody should know that when you speak in energy, you speak for a given container. And this is the advantage of speaking of entropy, because now the container is no more important.
Now, let's talk a little bit about enzymes.
Yeah.
That's what we had this morning. So, for me, when I was a student of medicine, enzymes always have been something magic. I did not understand why these proteins are so powerful. Water plays a role in making enzymes powerful.
What is wonderful is that these proteins make chemical reaction at room temperature and ambient pressure. This is that which is amazing. Because in chemistry, we can make any kind of reaction. If a reaction doesn't occur at a given temperature, at room temperature and ambient pressure, it's not a problem. We change the temperature, we change the pressure, and then the reaction will be okay. And what we have a trouble with that is that changing the pressure and changing the temperature means that it will cost money. And so we have, it has been discovered for a very long time, we have catalyst. See, we'll make a catalyst, and then with catalyst, the things will be much more easier to do without a lot of money to spend in terms of pressure and temperature. And the idea was that, in fact, enzyme was catalyst. To say they were very clever catalysts. But this is, as you told, something quite magical, because it's really efficient. It's not because when you work with our catalysts in chemistry, we increase a little bit the efficiency, but it is not amazingly efficient. But with enzyme, we have an amazing efficiency. And so, of course, I have think about that. And now, the quantum physics give you a key. Because I told you that the product of the Planck constant by the speed of light was homogeneous to an energy times a distance. And now you apply this relationship to not 1 micron, as before, but 1 nanometer. Because the common point of all the enzymes is that they are able to fold, and by folding they create a cavity. And inside this cavity, of course, you will find water, because water is everywhere in the cell. But the key point is that you have a cavity of about 1 nanometer of size. And when you translate this uncertainty on the size of the cavity, which is about what that is, when you put your molecule inside the cavity, you don't know where it is. It is somewhere in this 1 nanometer radius cavity. But this is an indetermination in position. Of course. So as this is indetermination in position, I have an indetermination on energy. Do you know the number? It is no more 16 zeptojoule. It is 16,000 zeptojoule for 1 nanometer.
That's a lot.
16,000. As I told you before, a covalent bond, which should be break for making new bonds, it is the role of the enzyme, break old bonds, create new bonds, it needs 1,000 zeptojoule. With 1,000 zeptojoule, you can break even diamonds. If you have 1,000 zeptojoule, even diamond could be broken. But now with 1 nanometer of ether, you have 16,000 of zeptojoule. And so you should see the enzyme as you put your molecule and she explodes inside the cavity, and the bonds are broken, and then you can reorganize them to make new bonds. When you leave the cavity, new bonds will be created, and all you have to do is to manage the flux by how many times we stay in the cavity before going out, and what's going in can be completely different what will be going out. Mm-hmm. Because inside you have a reactor, mm-hmm. which from the physical property of the vacuum, the quantum property of the vacuum, you can have up to 16,000 of zeptojoule of energy. Again, this is the idea that the energy is defined by the container. If I define the container, I define the energy. You cannot separate the energy from the container. So, of course, this is a huge amount. So this is why I was speaking here of a real vacuum. In fact, you have not a real vacuum, you have water inside. Because if you have 16,000 heptajoules, the enzyme will explode. So water is here to prevent the explosion and means that you can break some bonds, recreate new bonds, but not by exploding the whole thing. Again, water is always a stabilizing factor.
So you could change enzyme activity by changing the conditions enzymes find themselves.
You just have to change the shape of the cavity. It's magical. The shape of the cavity defines what you can do inside or not.
So the underlying phenomena of enzymes is quantum mechanics.
That's my viewpoint. Because, as I told you, quantum mechanics should be the right way of thinking at any scale. Even when I see a galaxy, I should use quantum field theory, not classical mechanics, not Newton's law. Newton's law are fossil concepts. We have new concepts, and we should use them in their full power. And the only break that we have in our head is that we see an object and we try to give to the object an existence by itself. And this is wrong. The object you see is always being destroyed. It disappears in the vacuum, and as soon as it disappears in the vacuum, it is recreated from the vacuum. It is a dynamic thing. When you look at one time, you may see the object or not, even if it is a galaxy. Because this works also for a galaxy. And what makes that you get the same object from the vacuum after having destroyed it, this coherence. Because by making the matter disappearing, you do not break the coherence. It's still there. Yeah. And as the coherence is still there, you create exactly the same object. And this is at a time scale which is so fast that what you see is an average picture which never change. But really, the galaxy disintegrates, but the coherence that was before the information, the coherence that was defining the shape of this galaxy, is not destroyed by the disappearance of the materials particle. They are destroyed, new materials particles appear, because energy should be conserved, and then, as the information, the coherence field is still there, you create exactly the same object with new components. This is the way nature is functioning. And this is very interesting to have this way, because when you have an object that you don't like, and you know that this object doesn't exist, it is a picture. It is always disappearing in the vacuum and reappearing. Maybe if I'm clever enough and interact at the time where it is disintegrating, I will change the coherence, and when it will reappear, it will have another shape. I will love this.
Let's take...
This is crucial. That is to say, you can let the object working with this internal vacuum, creation, destruction, creation, but you can also, interact with this object and change its shape, change its appearance. Of course, you will need to bring your own, this is called observation. And that means that if you are able to observe something, you can change this thing. This opens wide. things, because we can now speak about mental effect on matter. These are possible because matter doesn't exist. If matter was a real thing, we cannot work with ideas, observation. But if matter doesn't exist, and if it is what I tell you, that an object is always destroyed and recreated through a coherence which is not destroyed, you can change the coherence, you will change the object, because it is always in destruction and recreation.
I would like to take an example. When I was just thinking of somebody I met when I was working in Afghanistan, a mother who had lost her 5 children at the same day.
Yeah.
And they were hanging, the 5 children, right in front of her. And she said at the consultation, I cannot forget this moment I saw my 5 children dead hanging there. So the picture was very, very alive. So there was massive trauma. And this was the reality, almost only reality she found herself having this picture 24 hours, 7 times a week. Now, if we apply what you said, that we can through...
You can change that.
You can change that through, let's say, by interfering on the electromagnetic field, which are responsible for the coherent domains.
Yeah, you can interact with an object, yes.
Then this picture would start modifying. And that's happening because there is entropy flux increasing.
Yes, of course. Because if you want to change the things, you have to increase momentary release of entropy.
The question is still, in the healing process, what is the priority that needs to be addressed?
I cannot answer. I mean, that is not...
Well, I have my ideas on that.
Yeah,
I have my ideas.
No, I am not a physician, so... Yeah. When I am not in good health, usually I ought to see a physician, like you. But now I see no more physician, I just take a plant and hear music. But it works also. But this is another way of explaining what I try to explain. When you hear music, you change things.
Yeah, yeah. Because it creates resonance.
Yeah.
Yeah.
So it is better when I hear my plants which are singing.
Yeah. Yeah.
It costs me nothing.
Yeah.
Otherwise.
Yeah. Well, the point I try to make is when you talk about a picture, it can be a picture out there and it can be an inner picture. In this point, there is not a big difference.
All is a creation of fields.
Yeah.
And if you act on the field, you will change your reality.
Yeah, yeah.
And if your reality, you don't like it,
yeah.
But here I speak from a psychological point of view, not from a material point of view. But from a psychological point of view, if your reality is not, you don't like it, you have to know that you can change it. Because it is just temporary. It's something which is always creating and disappearing. And if you interfere with this process, during the destruction, you have the opportunity to put a new coherence that says when the object will be reconstructed, it will be different. Because you have changed the coherence. Mm-hmm. Mm-hmm. But for changing the coherence, you have to interact with the object. You cannot change the coherence by saying, the interaction can be for a psychological illnesses. It's just the healing mechanism is to take consciousness, to begin to be conscious of what you have experimented. Mm-hmm. You have an event which was very traumatizing.
Yeah, traumatizing.
And the simple fact, by your consciousness, to realize and not to deny it, to realize that this was something that you have been participating. This is you can be better health. Because you interact with the situation and you put new coherence, and this new coherence destroys the effects, the bad effects that it had before. And of course, here we are, what is called in medicine placebo effect. That is to say, this idea that by my mental picture I can change matter. This is not. This is in fact a real reality, and we can do that. Yeah.
Maybe what I'd like to elaborate is a little bit the question of irreversibility and aging. It's not such a super hot issue, and I'm very skeptical about what's done in this industry, because at the end everything has to be associated or leads to an increase in entropy to reduce the aging process. So can you talk us a little bit through irreversibility?
The phenomenon of aging is of course related to entropy. That's obvious. But aging is not. It means that the entropy flux is still there, the same, that never change. Between when you are young or old, the entropy flux is the same, or nearly the same. What has changed is that the older you are, the more you store entropy instead of discarding it. And this is, I would say, a natural process, because when entropy crosses you are making your body work. And you will create biomass for your body. And by working, of course, you will have to repair. As time goes on, you have to repair the things. And if you don't repair them, the entropy flux will be blocked at a certain point, and then you will accumulate entropy instead of discarding it. So one way of getting always young, it would be to, as soon as there is a blockage in entropy, you should remove it immediately. And you should never age. But this is a little bit ideal, because there is a very simple way of managing a system which is too old. You break it completely to make a new one. That is to say, you die, and then you have to birth again with new membranes, and then everything goes on. Because when you die, all your experience, your coherence that you have developed during your life doesn't disappear. Again, if you take the quantum field theory view, your body is destroyed and recreated, but the coherence has not disappeared. So in the newborn, you will get the coherence again. You will still be there, not with the same membrane, not with the same body, but you are still there as a conscious being.
Yes.
So that's the reason why we should not be afraid of death. Death is an opportunity to evolve, because the current container has done its job, and we need a new one which will be more in line with the new epoch, the new time. And this is how the cell works. I was very surprised by this when I learned biology. When I learned, for instance, how works microtubules.
Yeah.
You know microtubules? Yeah. It's you need to displace a vesicle, so you have a protein which is kinesin, which is a cargo, and she has to walk on microtubule. But instead of having always the same road, here, if you want to move a truck, you always use the same road. And sometimes the road is so damaged that you have to make it again. But in the cell, it's not like this. When you want to go one step beyond You create the road, and as you have no need of more of the road behind you, you destroy it. Creation, destruction, creation, destruction. It's much more efficient than keeping always the same structure. That is to say, you should be aware of that quantum field theory allows you to destroy the things. And it is not because you have destroyed it that it has disappeared, because the coherence is still there in the ether. You have the information, the coherence, and you can recreate your reality. And this is fortunate. It's very fortunate that we can do that. That things does not exist by themselves, but they are always disappearing and recreating. It's a very, very important point.